Space does not stop at the edge of the Milky Way. The universe does not close itself after the final shimmer of the familiar stars in the night sky. On the contrary, it opens like a shoreless ocean, so deep that human awareness has only brushed against a very small fraction of it. Amid that immensity, amid numbers that exceed the limits of intuition, a simple question naturally arises. What lies out there beyond? When you look up at the night sky, most of what you see consists of stars that belong to your own galaxy, the Milky Way, a vast spiral structure about 100,000 light-years across. Contains between 200 and 400 billion stars. That number alone already stretches the imagination. And yet, even so, it represents only a very small fragment of a much larger whole. The nearest large galaxy to us is Andromeda, roughly 2.5 million light-years from Earth. That distance is not only vast in a mathematical sense, but profound in time. When you see Andromeda, the light you receive left that galaxy at a time when humans were only just beginning to chip stone into tools. You are not merely looking at an object in the sky. You are looking into a past in which no civilization yet existed. Andromeda is larger than the Milky Way, possibly containing up to 1 trillion stars, a colossal structure, silently drawing closer. And in about 4.5 billion years, these two galaxies will meet, not in destruction, but in a slow transformation, like the dance of two giants. They will spiral into one another, merge, and eventually form a new galaxy. Yet even that event, monumental by every human standard, is only a small beat within a far greater cosmic symphony. The world around you, what is called the observable universe, does not contain merely a few dozen galaxies like the Milky Way or Andromeda. Recent observations suggest that the number may reach as high as 2 trillion. Each galaxy is a miniature universe, with hundreds of billions of stars and very likely billions of planets. The question is no longer whether we are alone, but why we ever thought we were. The first glimpse of this vastness came from a decision that seemed almost accidental. A telescope was pointed toward a region of sky that appeared empty. No stars, no light, no sign of anything remarkable. But after many days of collecting faint light, the resulting image completely transformed humanity's view of the universe. Within that seemingly empty void, thousands of galaxies appeared. Each galaxy was a world. If such a tiny patch of sky contained so much structure, what, then, was the rest of the sky concealing? Galaxies are not scattered at random. They arrange themselves into walls, filaments, and enormous planes stretching across hundreds of millions of light-years. Between these structures lie vast voids, regions where almost no galaxies exist. One of the largest known voids has a diameter of roughly 330 million light-years, yet contains only a handful of isolated galaxies. If Earth were located at the center of such a void, the history of science might have taken a very different path. Humanity might never have known that other galaxies existed at all. The filaments of matter connecting these galaxies form an immense framework. Like the skeleton that supports the body of the universe, this structure is known as the cosmic web. It is not composed solely of familiar matter, but largely of an invisible component, dark matter. It cannot be seen. It emits no light, yet its presence is inferred through gravity. When light from distant galaxies is bent as it passes through regions of space containing unseen mass, you know that something exists there, even though it reveals itself in no form of light. Simulations show that under the influence of gravity, both ordinary matter and dark matter naturally arrange themselves into network-like structures. Within these are enormous galaxy clusters, containing thousands of galaxies and masses so large that they defy all familiar comparison. There, collisions unfold over hundreds of millions of years. Galaxies merge, gas is compressed, matter is blown outward, sometimes igniting waves of new star formation, sometimes extinguishing the light of future stars. The wonder lies not only in what is happening, but in how humanity knows that it is happening, through redshift. As light from distant objects is stretched to longer wavelengths, observations reveal that the universe is expanding, and not merely expanding, but expanding at an accelerating rate. The cause is thought to be dark energy, a mysterious component that makes up most of the universe's energy content. Even though its true nature remains unknown, Looking beyond the Milky Way is not merely looking farther into space. It is also looking backward in time. Observing a galaxy billions of light years away is equivalent to seeing it when the universe itself was very young. New telescopes have opened this window. They reveal the first galaxies, small and chaotic, yet already containing the earliest stars that ended the dark age of the early universe. Some of them host enormous black holes, appearing far earlier than any prediction had anticipated. New questions arise in rapid succession, and then, amid all these structures that surpass imagination, another fact becomes even more astonishing. How can such small creatures, drifting on a pale planet, map the universe at all? How can a species that learned to write only a few thousand years ago measure the distances between galaxies? The answer lies in light. Each time you look up at the night sky, you are not merely seeing points of light. You are looking into a timeline, a map, a question that never grows old. And it is that very question, what lies out there beyond, that has carried you past the edge of the Milky Way and taken your first steps into a universe with no familiar end. There is a source of light quietly drifting through space, taking more than 2 million years to reach your eyes. It does not hurry. It carries no pre-written message. It simply exists, enduring, crossing the cold emptiness between galaxies. That light comes from Andromeda, the nearest neighboring galaxy to the Milky Way. When you see Andromeda with the naked eye, if you know exactly where to look, you are not merely observing a faint smudge in the sky. You are making contact with a moment from human prehistory. That light set out at a time when humans had no language, did not yet control fire, and left behind no cultural traces. It was an age when hands were still clumsily shaping stone, and upright posture had only just begun to take form. A distance of 2.5 million light-years is not merely a number, it is a delay in history. Space and time merge, turning light into the most faithful witness. When that light left Andromeda, Earth was still a raw and untamed world. When that light arrives, you possess the ability to understand where it came from. Andromeda is not a single point of light. It is a colossal galaxy, containing up to 1 trillion stars. Compared with the Milky Way, Andromeda is broader, denser, and more massive. If the Milky Way is like a vast city with hundreds of billions of stellar inhabitants, then Andromeda is like a supermetropolis, expansive, complex, and drawing ever closer. On the cosmic scale, Andromeda and the Milky Way are neighbors. The distance between them is small enough for gravity to create a long-term interaction. These two galaxies are moving toward one another at a speed of roughly 110 kilometers per second. The motion unfolds in silence, without sound, without visible signs. Yet it is irreversible. In about 4.5 billion years, the two galaxies will begin to merge, not as a violent collision of familiar imagination, but as a process stretching across hundreds of millions of years. Spiral arms will pass through one another. Stellar orbits will be bent. Gas and dust will be compressed, triggering new waves of star formation. In the end, another galaxy will emerge. The result of this slow union, that span of time lies far beyond every human scale. But what is remarkable is not the future event itself, but your ability to imagine it right now. From a small planet, you can chart the motion of an entire other galaxy, not through the senses, but through intellect. This leads to a deeper question. How can a species that emerged from mud, passed through ages of stone, metal, steam, electricity, and fundamental particles, come to know in advance the trajectories of structures beyond the reach of all direct experience? The answer lies not in power, but in patience. Everything begins with light. Light carries information about its origin, brightness, color, and variation over time all contain data. When humans learned how to read these changes, distance ceased to be an absolute barrier. Light became a ruler, a clock, a record-keeping system of the universe. For many centuries, Andromeda was regarded as nothing more than a faint cloud, a vague streak of light, grouped together with nebulae within the Milky Way. There was no firm reason to believe it lay beyond our galaxy. The sky then seemed more closed, more limited, more easily grasped. When the true distance to Andromeda was determined, that picture collapsed. The Milky Way was no longer the entire universe. It became just one galaxy among countless others. This shift did not strip humanity of a central position. It expanded awareness. Reality grew larger, and within that larger space, questions of meaning became sharper. The light from Andromeda does not tell only its own story. Every galaxy you see sends you a fragment of memory. All those fragments overlap, forming the history of the universe. You do not see the universe as it is. You see the universe as it once was. Perhaps one day, in a very distant place, another civilization will receive light from the Milky Way. That light will have left here at a time when humans first touched the atomic nucleus, first departed from the surface of their planet. When they observe that light, they will see your past. Just as you are now looking into the past of Andromeda. In that moment, there is no absolute center. There is no privileged viewpoint. There is only light, moving, carrying slices of time. The universe is not merely the place where you exist. It is the setting for every ultimate question you can ask. When you look at Andromeda, you are not only seeing a galaxy drawing nearer, you are seeing the capacity of intelligence to transcend biological limits. You are seeing the connection between the present and prehistory, between a creature capable of asking questions and a universe that never needed questions to exist. That 2-million-year-old light does not attempt to impress, it simply arrives. And in that slow arrival, it shows you that understanding is not an explosive moment, but a prolonged journey, where each time you look up at the sky, you stand simultaneously in the present and in a very distant past. When the night sky opens before your eyes, the first sensation is often distance, distant points of light, silent, seemingly detached from everything familiar. From that sensation, the idea of loneliness arises naturally. A small planet, a short-lived species, standing within an immense expanse of space. But that picture exists only when you have not yet looked far enough. The Milky Way was once considered the entirety of the universe. Then Andromeda appeared as an exception. After that, deeper observations completely altered the scale. Not a few galaxies, not a few hundred. New data indicate that the observable universe may contain as many as 2 trillion galaxies. That number is not merely large. It dissolves every old intuition about singularity and isolation. Each galaxy is a complete system. Hundreds of billions of stars orbit immense gravitational centers. Gas and dust condense into disks, spiral arms, and diffuse halos stretching across hundreds of thousands of light years. Within each galaxy exist countless planets. A fraction of them occupies stable orbits where physical conditions allow complex processes to persist. When the number 2 trillion is placed in its proper context, the familiar question begins to change shape. It is no longer whether there is anyone else out there. It becomes why the idea of loneliness ever existed at all. In a space containing such an enormous number of structures, life ceases to be a statistically rare possibility. It becomes an outcome that could occur many times. This perspective does not arise from speculation. It comes from images gathered through absolute patience. A telescope was pointed toward a region of sky that appeared empty. No bright stars, no signs of motion, just a quiet patch of darkness. But after many days of collecting faint light, that darkness revealed its true nature. Within a patch of sky smaller than the head of a pin, thousands of galaxies appeared. Each galaxy carried its own shape, its own color, its own history. Some were clear spiral galaxies. Some were aged elliptical galaxies. Some were distorted structures in the midst of merging. There was no emptiness in the familiar sense, only layers of structure lying beyond the initial threshold of perception. From that point, one thing became clear. The sky is not a flat surface scattered with points of light. It is a depth, where every direction of sight opens onto billions of stories. When you look into a dark point, you may be looking through millions of galaxies stacked along the dimension of time. This abundance forces a change in the idea of your position. There is no single center, no privileged direction of view. Every galaxy is a center from its own perspective. Every civilization, if it exists, could look outward and ask the same question you are asking now. In that context, loneliness does not vanish in an emotional sense, but it loses its physical foundation. Space is not empty. It is dense with structure. Vast distances no longer signify absence. but measure the time required for light to carry information from one place to another. When light from distant galaxies finally reaches here, it carries images of a younger universe. You do not see galaxies as they exist now. You see them at different stages of development. Some galaxies are erupting with star formation. Some have been quiet for billions of years. Some structures have only just emerged from the primordial darkness. All of these images coexist within a single moment of observation. The sky becomes an assemblage of many eras. When you look upward, you are not merely looking into space. You are looking into a spectrum of history, where present and past overlap. Within that picture, humanity is no longer an external observer. You are part of the very structure being observed. The atoms in your body once belonged to ancient stars. Those atoms passed through many generations of galaxies before becoming part of a thinking form of life. When this is recognized, loneliness transforms into something else, not abandonment within the universe, but placement within a vast network of connections. Each galaxy is a node within that network. Each point of light is a marker of physical processes unfolding over billions of years. The collapse of the idea of loneliness does not entail a loss of meaning. On the contrary, it expands the space in which meaning can arise. When you are no longer the sole center, you are free to understand your existence within a larger context. Meaning no longer comes from a privileged position, but from the capacity for awareness. 2 trillion galaxies do not need humanity in order to exist. But only when a being can recognize that number does the universe become something that can be contemplated. In the moment you understand that the sky does not end in any direction, something else happens as well. The boundary between inside and outside begins to blur. You no longer stand before the universe as something separate. You are within it, looking out at other parts of the very structure to which you belong. Loneliness, if it still exists, is no longer a conclusion. It is only a temporary feeling, arising when vision has not yet expanded far enough. And when vision does expand, when 2 trillion galaxies stand revealed as real entities, the old question no longer retains its original form. In its place emerges a quiet realization. In a universe so dense with structure, the very act of seeing, understanding, and asking questions is already a deeper connection than any signal that could ever be sent. There are moments when what changes perception does not come from a spectacular discovery, but from daring to look longer at a place that seems to contain nothing. For most of history, the night sky was read as a sparse map. Bright stars were remembered. Dark regions were ignored. Empty space was assumed to be truly empty. That assumption held until a simple decision overturned the entire way of seeing. A telescope was aimed at a patch of sky with no obvious features, no bright stars, no nebulae, no intuitively compelling target. Just a small, silent, dark region, seemingly unworthy of attention. But instead of moving on, observers chose to stay. Faint light was collected over many days. Time layered upon time. Patience replaced habit. When the data were combined, the emptiness vanished. Within that tiny frame, thousands of galaxies appeared. Not random smudges, but complete structures, each with its own shape, color, and history. There were young spiral galaxies. There were old, rounded, quiet galaxies. There were distorted structures in the process of merging, as if recounting collisions that unfolded over hundreds of millions of years. What was shocking was not only the number, but the location. These galaxies did not lie in some specially distant corner of the sky. They appeared in a patch that had previously been considered empty. The void, it turned out, was only a limit of vision. Given enough light, the sky always has something to reveal. From that moment on, the concept of emptiness began to unravel. Space is not a black backdrop against which luminous objects stand out. It is a depth, where layers of structure overlap across time. Looking into a dark point is no longer looking into nothingness. It is looking through billions of light years, through eras when the universe was profoundly different. The Hubble Deep Field did more than provide images. It forced an adjustment in the way of thinking. If such a tiny patch of sky contains thousands of galaxies, then how much is the rest of the sky concealing? And if those galaxies exist at different distances, then every point of light you see is a distinct moment in time. Within a single frame are galaxies that are closer, whose light departed when Earth already hosted complex life. There are galaxies far more distant, whose light began its journey when the universe was still young, when the first stars were just igniting the darkness. The image is not a simultaneous slice. It is a slice of history. That is where the shock to perception lies. The sky does not merely show positions. It shows processes. When you look deeply, you see evolution. Space becomes time laid out before you. Emptiness turns into a library, where each point of light is a page. From here, the question of how galaxies are distributed also changes form. They are not scattered at random. They arrange themselves into vast structures, walls and filaments stretching across hundreds of millions of light years. Between these structures lie sparse regions, enormous voids. Yet even these voids are not absolutely empty. They are simply less dense, not non-existent. If Earth were located at the center of such a sparse region, the history of perception might have unfolded differently. The sky would have appeared poorer, fewer signals, fewer clues, not because the universe was different, but because the point of observation was different. Knowledge, in this case, is not only a product of intellect, but also of circumstance. The Hubble Deep Field reveals an uncomfortable but necessary truth. What you do not see does not mean it does not exist. The limits of observation are not the limits of reality. By changing the way you look, the length of time you look, or the tools you use to look, the entire picture can change. From that perspective, the sky is no longer a quiet dome. It is a dynamic space, where every direction contains information. If you are patient enough to wait, even the faintest light carries the story of billions of years. What matters is not finding the brightest place, but refusing to ignore the darkest one. The shock to perception does not arrive with an explosion. It arrives through prolonged silence, where data accumulate bit by bit until they can no longer be ignored. When the complete image emerges, there is no returning to the old way of seeing. Emptiness is no longer empty. It becomes a reminder of humility. From that moment on, every time you look up at the sky, the ideas of empty and full are transformed. Space does not distinguish between places worthy of attention and places that are not. That distinction exists only in the expectations of the observer. The universe does not. The Hubble Deep Field does not answer every question. It does not explain why structures appear as they do, but it accomplishes something more important. It forces you to acknowledge that intuition is insufficient, that the greatest voids sometimes conceal the highest density of information, and that perception, to move forward, must dare to remain with what seems to contain nothing. When emptiness collapses, space expands in a different way, not in size, but in meaning. You no longer see the universe as a place with more or less. You begin to see it as a place that can be read, if you are patient enough to listen to the faint light passing through. When you look deep enough, the universe does not appear as a chaotic scatter of galaxies. It reveals a vast, quiet order, existing beyond every initial intuition. The points of light you see do not stand alone. They are connected by structures stretching across hundreds of millions of light years. A colossal network that supports the entirety of observable space. Galaxies gather along long, thin strands called filaments. These strands intersect at nodes, where massive galaxy clusters form. Between the strands lie enormous gaps called voids, where the number of galaxies is so sparse it is almost an absence. The full architecture forms what is known as the cosmic web, the skeleton of the cosmos. The first feeling when confronted with this web is surprise. Order appears on a scale larger than anything ever familiar. Not a rigid order, but the order of gravitational flows, where matter moves along invisible pathways shaped from the very beginning. Filaments are not perfect straight lines. They curve, branch, and vary in thickness. Along them, gas and dust accumulate, creating conditions for galaxies to form and evolve. At the intersection nodes, where multiple filaments meet, great clusters are born, containing hundreds to thousands of galaxies, bound together by shared gravity. Between these structures are the voids, vast regions of space, sometimes hundreds of millions of light years across, where there are almost no galaxies. Voids are not random holes. They are the inevitable outcome of the same process that creates filaments. As matter is drawn into the strands and nodes, The remaining regions grow increasingly thin. If you imagine the universe as a living body, then filaments are the supporting vessels, and voids are the empty spaces required for the structure to exist. Without voids, the web would have no shape. Without filaments, there would be nowhere for galaxies to gather. The two coexist, complementing one another. This web is not built primarily from familiar matter that you can see. Most of the mass that forms this skeleton comes from an invisible component. Dark matter governs the formation of the web from the earliest stages of the universe. When the universe was very young, small fluctuations in density were amplified by dark matter, pulling ordinary matter along. Little by little, over time, slightly denser regions became the seeds of filaments. Gravity made the rest slide toward them. Voids expanded, not because they were pushed outward, but because matter was withdrawn from them. Order grew, slowly, without any need for design. Numerical simulations show that this process unfolds naturally, given gravity and time. The cosmic web forms on its own. No external intervention is required. No purpose is required. And yet the result carries a cold beauty, precise, almost architectural. This introduces a subtle shift in how you see space. Space is no longer an empty background with galaxies placed upon it. It is a dynamic structure where matter flows, gathers, and then thins. Every galaxy you see is a small node within a far larger web. Your position within this web is not special. The Milky Way lies on an ordinary filament, in a moderate galaxy group, neither too dense nor too isolated. Yet that very middling position allows a broad view. Too close to a dense cluster, and the sky would be dominated by nearby galaxies. Deep within a void, and the sky could be so poor it would mislead perception. Knowledge, in this case, is not only the result of observational capacity, it is also the consequence of position within the web. You see the universe this way because you are here, in a node quiet enough to observe, and rich enough to infer. Once you understand this, the cosmic web is no longer an abstract diagram. It becomes the context for every question you ask. Every light you see has traveled along that web. Every galaxy is a point on the skeleton you are trying to imagine. Voids, though empty, play a central role. They create contrast. They allow filaments to stand out, like silence in music. Voids clarify the melody of structure. Without them, the universe would be flatter, harder to read. The cosmic web matters not because it is beautiful, but because it shows that order can emerge from simple laws, given enough time. It does not require an observer in order to form, but only when an observer exists can that order be recognized. When you imagine filaments stretching across hundreds of millions of light years, linking distant galaxy clusters, you are seeing the skeleton of reality, a structure you cannot touch, cannot hear, yet can infer from motion and light. The cosmic web does not say that the universe has a purpose. It says that the universe has a shape, and that shape exists independently of feeling, but not independently of understanding. When you recognize filaments and voids, you do not merely learn more about space. You learn how to see beyond your first intuition. In the silence of vast emptiness and the density of matter strands, the universe reveals its own framework, without display, without invitation, simply present. And when you recognize that web, the way you look at the night sky is no longer the same. You no longer see isolated points of light. You see signs of a structure that is holding everything up. There are things that become clear only when they are absent. In the universe, knowledge does not always come from regions dense with light. Sometimes it is precisely the places that contain almost nothing that shape how you understand everything else. Vast empty regions, the great cosmic voids, are not flaws in the structure. They are an essential part of the picture. Voids are regions of space so large they are difficult to imagine. They can stretch across hundreds of millions of light years, where the number of galaxies is so small that light itself becomes sparse, not completely empty, but sparse enough that the sky, from within, appears impoverished. It is this impoverishment that proves decisive. In the cosmic web, filaments and galaxy clusters attract matter. Matter slides along the strands and accumulates at the nodes. What remains is drawn away, leaving behind underdense regions. Voids grow over time. not because they are intentionally created, but because everything around them is pulled elsewhere. Absence is the result of the same laws that produce presence. If you were to stand inside a void, the sky would be different. Fewer galaxies, fewer signals, fewer clues from which to infer. Space would not feel rich, but closed in, not because the universe is smaller, but because the signals required to perceive its scale lie too far away. In such a scenario, the history of knowledge might have unfolded differently. When the sky is poor in light, large hypotheses struggle to take root, not because intelligence lacks capacity, but because data are insufficiently rich. Knowledge does not depend solely on the power of thought. It depends on what can be observed from the position one occupies. This leads to an uncomfortable truth. Perception is not entirely objective. It is constrained by circumstance. You do not see everything as it is. You see what your position allows, and from what you see, you construct a picture of the whole of reality. Voids, therefore, are not merely objects of study. They are lessons in limitation. The absence of light does not mean the absence of structure. The lack of easily visible structure does not mean the absence of law. Absence is not nothingness. It is a different state of distribution. In three-dimensional maps of the universe, voids appear as hollow cavities between strands of matter. They make filaments stand out. They create the contrast necessary for structure to be read. Without voids, the web would lose its shape. Just as writing requires spaces to convey meaning, the universe requires emptiness to reveal its structure. Absence also carries a deeper significance. It forces you to think about the conditions under which knowledge arises. Not every place makes it easy to ask large questions. There are regions of the universe where the sky does not contain enough data to provoke inference about other galaxies. In such places, mistaken conclusions could persist for a very long time without being challenged. Knowledge, in this sense, is not the inevitable outcome of intellectual evolution. It is the result of a coincidence of location. You are situated close enough to filaments for the sky to be rich in information, but not so close that local light overwhelms everything else. That position allows a balanced view. Voids also reveal another aspect of the universe. They are not static. They expand over time. As matter continues to slide toward denser structures, this expansion makes filaments stand out more clearly, sharpening the cosmic web. In that sense, voids are a quiet engine that allows order to emerge. In models of cosmic evolution, voids function as natural laboratories. Within them, gravitational effects are weaker. The rare galaxies that exist inside voids evolve more slowly, experience fewer collisions, and are less disturbed. Comparing galaxies in voids with those in dense clusters allows a clearer understanding of the role environment plays in shaping structure. But the most important consequence lies at the level of awareness. When you understand that absence can shape knowledge, you become more cautious with every conclusion. Not every gap is a deficiency. Sometimes, the gap itself is information. In music, silence defines rhythm. In text, white space defines meaning. In the universe, voids define how structure is perceived. This parallel is not accidental. It reflects a general principle. Order is determined not only by what is present, but also by what is not. When the night sky opens before you, the dark regions are no longer meaningless background. They are part of a structure that is telling a story. Each dark region hints at flows of matter that have departed. Each empty space emphasizes the strands that carry light. Absence, therefore, is not a failure of observation. It is a reminder of context. Knowledge is always built from a specific position in space and time. You understand the universe in this way because you are standing here, looking outward, between filaments and voids. Once this is recognized, the question of objectivity and subjectivity becomes more subtle. Not everything depends on the observer, but the path to understanding does. And that path passes through regions filled with light as well as through silent darkness. Empty spaces do not suggest that the universe is lacking. They suggest that the universe is distributed. And within that distribution, knowledge arises not only from what is dense, but from how density and sparseness interact. When you accept this, the night sky is no longer divided into places that are something and places that are nothing. It becomes a single whole, in which both presence and absence together determine what can be known. There is something that holds the universe together yet never reveals itself. You do not see it shine. You do not see it reflect. You cannot touch it with any of your senses. But without it, what you are looking at could not exist in its familiar form. Galaxies would not retain their shapes. Clusters would fall apart. The cosmic web would never form. That something is called dark matter. When the motion of galaxies was first observed, a paradox appeared very early on. Stars at the outer edges of galaxies rotate almost as fast as stars near the center. According to everything known about gravity, this should not happen. If only the visible mass were present, outer stars would rotate much more slowly, or even be flung outward, but they do not escape. They are held in place by a mass that does not reveal itself. That mass does not emit light. It does not absorb or reflect light. It reveals its existence only through gravity. When light from distant galaxies is bent along paths that cannot be explained by ordinary matter, you know that something is acting there, though unseen. It leaves its imprint in motion, from the scale of individual galaxies to the scale of galaxy clusters. The evidence repeats. Large clusters containing thousands of galaxies possess far more mass than their light alone can account for. When clusters collide, the hot, glowing gas slows down and remains near the center, while most of the mass continues straight through. Unhindered, gravitational maps show mass located where there is no light. This forces a change in how the universe is understood. What you see is not the main component. Light only sketches the surface. The structure-defining substance lies beneath, invisible, yet governing all motion. Dark matter makes up most of the universe's matter content. Ordinary matter is only a thin layer that follows it. In models of structure formation, dark matter appears early. When the universe was still very young, it began to clump into massive halos. These halos acted as scaffolding. Gas and dust, under gravity, fell into them, cooled, condensed, and eventually formed stars and galaxies. Light came later. The foundation came first. Without dark matter, galaxies would not have formed quickly enough before cosmic expansion pulled everything apart. Without invisible halos as anchors, ordinary matter would disperse. There would be no spiral disks, no large clusters, no cosmic web, no skies like the one you see. What is striking is that dark matter does not interact with light in any familiar way. It passes through everything almost without collision. It does not form stars. It does not create small-scale structures. It simply exists quietly, pulling everything else into order. Many hypotheses have been proposed to explain its nature. It could consist of heavy, weakly interacting particles drifting through space. It could be made of extremely light particles, spread out like a field. There are also ideas suggesting that dark matter is not a particle at all, but a sign of gravity not yet fully understood. So far, none of these possibilities has been directly confirmed. Experiments searching for dark matter are placed deep underground, where interference from cosmic radiation is minimized. Detectors wait for rare interactions, for extremely faint signals. The long silence is not failure. It is a reminder that the universe does not easily reveal its foundations. Dark matter thus becomes a lesson in indirect knowledge. You do not know it by seeing it. You know it by observing consequences. Through motion, through stability, through things that do not collapse when they should. In science, some entities are confirmed through relationships, not images. This carries a deeper implication. Reality does not need to be visible to be effective. What matters most may be what never appears before your eyes. Dark matter does not need to be recognized in order to perform its role. It only needs to exist. When you look at the night sky, you see galaxies glowing like islands, but most of the mass that holds those islands together never shines. The filaments you imagined earlier are woven primarily from dark matter. Light merely traces the outline of a deeper structure. This understanding changes how you define seeing. Seeing is no longer sufficient for knowing. Knowing sometimes comes from accepting that some foundations cannot be directly observed. Knowledge becomes the art of inferring from traces, not from images. Dark matter also imposes a humbling limit. Even though its large-scale distribution has been mapped, its microscopic nature remains beyond reach. The universe allows you to see the shape of its skeleton, but not to touch the material from which it is made. In that silence, A beautiful paradox emerges. Everything you see, brilliant galaxies, stellar clouds, majestic structures, depends on something you never see. Light requires darkness to have structure. Presence requires absence to have a foundation. Dark matter does not make the universe mysterious in a meaningless way. It makes the universe more honest. It reminds you that reality is not designed to suit human senses. It exists according to its own rules. And if you want to understand it, you must learn to listen to very indirect signals. When you accept that the foundation of all visible structures is invisible, the way you look at the sky changes. You no longer search for light as the final goal. You begin to search for the laws beneath the light. And in doing so, you realize that the universe is built not only from what shines, but from what quietly supports everything above it. There is a force that does not need to touch anything, yet still pulls everything away from everything else. It does not shine. It does not clump. It does not form shapes. It does not exist as an object. It exists as a tendency, a trend spread throughout space, quiet yet relentless. That force is called dark energy. For a long time, the expansion of the universe was considered a natural consequence of its hot, dense beginning. But intuition also suggested that this expansion should slow down. The gravity of all matter, visible or not, ought to pull everything back together, like a stone thrown upward that eventually falls. The universe should have decelerated over time. Precise observations overturned that intuition. When distances to very distant galaxies were measured and compared with the speeds at which they are receding, something unexpected appeared. The universe is not slowing down. It is expanding faster, not only fast, but accelerating with time. This does not originate from any specific place. There is no central source of force, no preferred direction. Every region experiences the expansion equally. Galaxies are not racing through space. Space itself, between them, is growing. Every distance increases a little, then more still. To explain this, a new component was added to the picture. Dark energy is not like dark matter. It does not provide scaffolding. It does not pull. It pushes, not in the familiar mechanical sense, but in the sense of causing space itself to expand. Dark energy exists everywhere, evenly distributed throughout space. It does not need matter to cling to. It does not require a source to be generated. As space expands, the amount of dark energy within that space does not decrease. On the contrary, the total energy increases with volume, an idea that runs counter to everyday intuition. According to current measurements, dark energy makes up the majority of the universe's energy content. Dark matter comes next. Everything that shines, from stars to galaxies, accounts for only a very small fraction. This does not merely alter physical equations. It changes how you imagine the place you inhabit. You do not live in a universe dominated by light. You live in a universe governed by darkness. Not the darkness of emptiness, but the darkness of components that do not directly reveal themselves. Dark energy is the factor that determines the long-term fate of all structures. On small scales, gravity still prevails. Within galaxies, star systems, and planetary systems, attraction holds things together. But when you look farther out, across hundreds of millions of light years, a boundary appears. Beyond that boundary, dark energy begins to dominate. Galaxy clusters drift apart, filaments are stretched, voids widen. If this trend continues, the future of the universe will become increasingly isolated. Galaxies will drift so far apart that their light will no longer reach one another. Each group of structures will become a permanent island, floating in an ever emptier space. Cosmic history, in any observable sense, will gradually fade away. This highlights a subtle truth. You are living at a special moment. The universe is old enough to have formed galaxies, stars, and planets, yet not so old that those structures have been pulled beyond view. This is the era of observability, a fragile interval that will not last forever. Had you been born very early, there would have been nothing to observe but hot gas and background radiation. Had you been born too late, you would see only a lonely galaxy, with no clues to a vast universe beyond. The present lies between those extremes, not by design, simply as a consequence of cosmic evolution. Dark energy, therefore, is not merely a parameter, it is context. It defines what can be seen, and for how long. It sets the limits of cosmic memory. When light from distant galaxies can no longer reach here, their history does not vanish, but the ability to know it does. There are many interpretations of the nature of dark energy. It may be a constant intrinsic to empty space. It may be the manifestation of a background energy field, extremely weak, yet never zero. It may also signal that our understanding of gravity is incomplete. At present, no final answer exists. What is striking is that dark energy cannot be sensed directly. No tabletop experiment reveals its presence. It shows itself only through the overall behavior of the universe, through the fact that everything grows farther apart faster than expected, through the mismatch between intuition and data. This forces an adjustment in thinking. Not every force behaves like a force. Not every cause has a local expression. Some influences reveal themselves only when you look wide enough, long enough, and are patient enough to accept results that defy expectation. Dark energy also carries a quiet, existential meaning. In a universe being stretched apart, where everything gradually separates, moments of connection become more precious, not because they are rare, but because they are temporary. The light you receive today may be the last light from a very distant region. When you look at the night sky, the stillness does not come only from distance. It comes from a process underway. Slow yet unceasing. Space is expanding. History is being drawn out. Stories continue, but listeners grow fewer. Dark energy does not need to be personified. It does not threaten. It has no intent. It exists simply as a background condition. Yet for that very reason, it reminds you that the universe is not built around human familiarity. It operates according to laws indifferent to whether anyone is watching. When you accept that this silent push is shaping the future, the way you see the present changes, not to induce anxiety, but to foster understanding. That the ability to see, to measure, to ask questions exists within a finite window of time, and within that window, dark energy is not only a mystery to be solved, it is a reminder of the fragility of all structures, and of the value of understanding, while understanding is still possible. There is a truth that is easily overlooked when speaking about the universe. Not every era allows itself to be seen. Not all times permit light to tell its story. Observability is not a default state of existence. It is a brief, fragile phase, and you are living precisely within it. The universe has spent most of its history under conditions that could not be observed. Immediately after its beginning, everything was too hot, too dense. Light was trapped, endlessly colliding, unable to travel freely. There were no images, no horizons, only energy and chaotic motion. Then came another long period, when the universe had cooled but stars had not yet formed. Space was filled with cold, dark hydrogen gas. Light had not yet been born. Only when the first stars ignited did the universe truly enter an era that could be seen. Light began its long journey through expanding space. Galaxies formed. Large-scale structures gradually emerged, and at the same time, observability was activated. Not because there were observers, but because physical conditions allowed light to exist, to propagate, and to carry information. This era does not last forever. Dark energy, as you already know, is stretching space at an ever-increasing rate. With every passing moment, regions of the universe are pushed beyond the reach of light. Light from those regions will never arrive, not because it is blocked, but because the space between you and its source expands faster than light itself can travel. This means that the map of the universe is not fixed. It is shrinking in a perceptual sense. What can be seen today will no longer be visible in the very distant future. Galaxies that are present now will gradually vanish from the sky, leaving no observable trace. If you were born far enough into the future, you would have no direct evidence that the universe was ever vast. No distant galaxies, no cosmic background radiation, no clues of expansion. Every observation would suggest a static, isolated universe, containing a single lonely galaxy. Not because the universe was once like that, but because all evidence has been pulled beyond view. This places the present moment in a special position, not in a central sense, but in a conditional one. The universe is mature enough to host complex structures, yet not so old that it has erased its own history. You are living in that interval, a rare window in which the past can still be read. Every photon reaching your eyes today is a fragment of memory. It carries information from a moment long gone, perhaps millions or billions of years ago. When that light slips beyond reach in the future, the memory is not erased from the universe, but it is erased from awareness. The observable era is not merely an astronomical condition, it is the foundation of knowledge itself. Every theory about the origin, structure, and fate of the universe depends on light still being able to arrive. When light no longer arrives, knowledge cannot expand. It can only close in on increasingly limited models. This shows that awareness depends not only on intelligence, but on cosmic context. Intelligent beings may exist in the very distant future, yet they will never know of a vast universe, not because they lack capability, but because the data have disappeared. For this reason, science today is not only discovery, it is preservation. Every measurement, every map, every recorded spectrum is an act of conservation, not only for future generations, but for humanity's own future capacity to understand. When you look up at the night sky, you are not only looking into space, you are looking through a window that is slowly closing. Every distant galaxy is an opportunity passing by. Every large structure is information that exists only for a finite time. The observable era also shapes the questions you are able to ask. You can ask about beginnings because their traces remain. You can ask about structure because the cosmic web is still visible. You can ask about fate because expansion can still be measured. These questions will not always be available. This does not make awareness pessimistic. It makes it precise. Knowledge is not a guaranteed right. It is the outcome of a coincidence between physical conditions and cognitive capacity. When those two intersect, understanding arises. When one disappears, understanding stops. This era also highlights the role of curiosity, not because the universe demands to be understood, but because the window is open. There is no guarantee it will remain open, no sign that every mystery will be resolved in time. But the ability to ask questions exists precisely because light still arrives. In that context, awareness becomes a temporary yet profound phenomenon, a brief response of matter before observational conditions fade away. Not a privilege, but a phase. You do not need to see this era as a stroke of purposeful fortune. It was not designed for anyone. It simply happened. Yet, precisely because it lacks built-in purpose, understanding becomes more valuable. Not because the universe needs to be understood, but because the capacity to understand does not last. While light still tells its stories, listening matters. While the sky remains filled with traces of the past, reading them becomes a form of presence, not to conquer, but to acknowledge. The observable era is not the pinnacle of the universe. It is a gap in the flow of time, where light, structure, and awareness coincide, and you are standing within that gap, not to possess it, but to witness it. There are moments when the universe forces awareness to pause, not because data are lacking, but because data arrive too early compared with what theory allows. James Webb opens such a moment, not through familiar light, but through photons stretched beyond the threshold of human vision. From the deep infrared, ancient signals step into the present. Webb does not see the universe as the naked eye does. It listens to light that has been stretched for billions of years. That light set out when the universe was very young, when structures were only beginning to form. To receive it, Webb had to leave Earth and place itself in cold, silent stillness, where temperatures are low enough that thermal vibrations no longer drown out the faint signals of cosmic dawn. From that position, Webb began sending back its first images. They were not calm pictures. They were questions. Galaxies appearing when the universe was only a few 100 million years old. Not small as expected, not chaotic as predicted. Some show clear structure. Some have large masses. Some shine more brightly than models allow. In familiar scenarios, the time required to form large galaxies is long. Matter must gather. Gas must cool. Stars must form, die, and enrich the environment with heavy elements. But what Webb sees appears to have skipped many steps, as if the universe learned how to organize itself faster than humans had thought. These galaxies do not merely exist early, they exist forcefully. There are regions of intense starburst activity. There are brilliant cores, signs of supermassive black holes. And the most puzzling aspect is their size. How could a black hole reach billions of solar masses when the universe itself had barely had time to age? These questions are not details. They touch the foundations of how cosmic evolution is understood. Either galaxies formed far more rapidly than predicted, or the initial conditions were different from what the standard model assumes, or there are mechanisms not yet included in the equations. Webb does not only take images, it reads spectra. In each streak of light are traces of elements: hydrogen, helium, carbon, oxygen, even water vapor. These chemical letters reveal how early stars were born, died, and recycled matter. They tell a story more complex, earlier, and richer in structure than expected. When Webb looks toward cosmic dawn, it does not look at a single moment. It looks at a process, a long dark age, when there were no stars, when light did not yet exist. Then a transition. Gas clouds collapsed. The first stars ignited, brief but violent. Their first light ionized the surrounding space, ending the ancient darkness. Webb shows that this moment was not simple, not a single flash, not a neat step. It was a sequence of overlapping events, where bright regions appeared, spread, faded, and then flared elsewhere. An uneven dawn, yet no less decisive. What is striking is that Webb does not confirm what humans expected. It does the opposite. It forces models to adjust. When data conflict with predictions, science does not hide the inconvenience. It records it, compares it, and accepts that current understanding is provisional. In this context, Webb becomes a test of intellectual attitude, not of who is right or wrong, but of how willing foundational assumptions are to change. The universe has no obligation to fit models. Models exist to keep pace with the universe, not the other way around. Webb also highlights something subtle. The light it records set out when Earth did not yet exist, when the sun had not formed, when the Milky Way was still an unbound cloud. Yet that light still arrived here, was collected, and was decoded, with no purpose, with no intention, simply as a consequence of physical laws and instrumental patience. In every image lies a quiet paradox: galaxies that should not exist, yet do, not to challenge, but to remind that surprise is an essential part of discovery. When everything fits, knowledge stalls. When there is mismatch, understanding advances. Webb also reshapes the relationship between technology and memory. It does not merely extend vision. It preserves epochs that the future will no longer be able to see. As dark energy continues to stretch space, the most distant regions will disappear beyond reach. Webb records them before that happens. For this reason, each dataset is not merely a measurement. It is an act of preservation, not for nostalgia, but to retain context, so that when questions are asked later, fragments of evidence from the dawn still remain. Webb does not answer every question. It creates more, but that is not failure. It is the sign of a tool correctly placed. Cosmic dawn, as Webb reveals it, is not a closed chapter. It is a region being reread, with sentences that should not be there, yet are. And in confronting galaxies that should not exist, awareness learns a fundamental lesson. The universe is not constrained by human comfort. It unfolds according to its own rhythm. When patience is sufficient to listen, what appears will not only be images, but a profound adjustment in how one understands living within a universe rich with surprise. Light does not only show you places, it shows you time. Every photon that reaches your eyes is a message that left its source long ago, carrying the imprint of a moment that no longer exists. When you look up at the sky, you are not standing before the present. You are standing before a vast archive, where history is written in the long journeys of light. At first, light was only a physical phenomenon, an electromagnetic oscillation propagating through space. But when humanity learned to measure, compare, and decode it, light became memory. Not human memory, but the memory of the universe. A memory not written in words, but in wavelengths, frequencies, and intensities. Every light source carries the signature of the conditions in which it was born. A young star emits a different spectrum from an old one. A galaxy undergoing intense star formation leaves a different signature from a galaxy that has exhausted its fuel. When light departs, it freezes that information and carries it across expanding space. By the time light reaches here, it has been stretched. Its wavelength has increased. Its color has shifted toward the red. This effect is not noise. It is data. From the degree of stretching, you determine distance. From distance, you infer time. In this way, light becomes a ruler of the past. To read this memory, humanity had to learn a non-intuitive language, not shapes, but spectra. When light passes through a prism or a spectrograph, it separates into bands of color. Within those bands are dark and bright lines, small gaps. Each line corresponds to an element: hydrogen, helium, carbon, oxygen, the basic letters of the universe. By reading these lines, you learn what environment the light has passed through. You learn where gas is present. You learn whether stars have been born or have died. There is no need to see directly. It is enough to read the consequences. History is not told through continuous images, but through discontinuous traces. When distances become too great, light grows faint. Humanity must find particularly stable sources of light to serve as reference points. Cosmic beacons. They allow a comparison between intrinsic brightness and observed brightness, from which distance can be inferred. Step by step, from near to far, a distance ladder is constructed. This ladder is not perfect. Each rung carries uncertainty. But when many independent methods converge on the same result, reliability emerges, not because it is absolutely precise, but because it is consistent. The history of the cosmos is read not through a single measurement, but through the overlap of many lines of evidence. When light comes from very far away, it carries traces of a time when the universe was young, small, hot, chaotic galaxies, regions of gas not yet enriched by generations of stars. Looking at them, you see the universe learning how to organize itself, not by design, but by law. Light also carries limits. You can read only what has arrived. There are regions from which light has not yet had time to depart. There are epochs in which light did not exist. These gaps are not random absences of data. They are part of the story. They tell you when the universe was silent. This makes reading the history of the cosmos an art of balance, between what is present and what is absent, between signal and silence, between data and inference. Humanity does not see the entire book. It can read only the pages that have flown here. Light also teaches a lesson in slowness. There are no instant answers. All information arrives late. When you look at a galaxy billions of light years away, you are receiving a message sent long ago, with no opportunity for revision. History arrives as it was. In that process, awareness learns humility. You cannot demand that the universe update itself to your needs. You cannot question the past again. You can only read what remains. And it is precisely this limitation that creates reliability. Light does not know it is being observed. It was not sent to persuade. It simply travels. As instruments become ever more sensitive, the memory carried by light becomes more detailed. Long wavelengths reveal cold and distant regions. Short wavelengths reveal hot and nearby ones. By assembling them together, a layered picture emerges, not a single moment, but a long sequence of transformations. The history of the cosmos carries no commentary. It does not explain itself. Humanity is the one that asks questions, but light is the one that answers, in its own way. Without emotion, without intention, only information. When light is treated as memory, observation ceases to be a passive act. It becomes a form of reading, not reading to reach quick conclusions, but reading to understand the structure of the narrative. A narrative with no central character, no climax in the familiar sense, yet possessing an internal order. Every measurement of light is a sentence added to the cosmic manuscript, not to complete it, but to clarify it. And when many sentences are placed side by side, you begin to perceive rhythm, the rhythm of expansion, the rhythm of formation, the rhythm of decline. Light, in this role, is not merely a scientific tool. It is a bridge between the present and times that cannot be reached. When you listen to the sky, you are not only collecting data, You are receiving the memory of a reality larger than yourself, and in learning how to read that memory, humanity does not only learn more about the cosmos, it learns more about its own capacity to understand. That knowledge does not come from seeing more clearly, but from learning how to decode extremely fragile signals. Light does not tell stories in words, but if you are patient enough, you will realize that the entire history is still being whispered, endlessly, in every photon that has just arrived. Distance in the universe is not a simple number. It is not measured with a ruler, nor can it be guessed by intuition. When you see a faint point of light in the sky, you do not know whether it looks small because it is far away or because it is intrinsically weak. To read the history of the cosmos, humanity had to solve this foundational question first. How far is far? At first, there was only apparent brightness. A star that looked dimmer was assumed to be farther away. But very quickly, that way of thinking revealed its flaw. A large star far away can look exactly like a small star nearby. Light, without a standard, becomes a deceiver. A fixed reference was needed, not a reference of position, but a reference of luminosity. Sources whose intrinsic brightness is known, no matter where they are. By comparing true brightness with observed brightness, distance can be inferred. From that need, the cosmic distance ladder was born. The first rung of this ladder came from variable stars with regular rhythms. They brighten and fade on stable cycles. What mattered was not the variability itself, but the relationship between the period and intrinsic brightness. The longer the period, the brighter the star. This relationship makes it possible to infer true luminosity simply by measuring the time of the oscillation. Such stars became the first standard candles beyond the immediate neighborhood. They do not take you to the edge of the universe, but they are enough to reach beyond the galaxy. From there, a leap in awareness occurred. Once the distances to nearby galaxies could be measured, the universe expanded from a single structure into many independent structures. But this rung has limits. The light of these stars is too faint to be seen at very great distances. To go farther, a brighter source was needed, rarer, but stable in a different way. The answer came from the death of stars. A special type of supernova explodes with nearly the same peak brightness under all circumstances. For a brief moment, it can outshine an entire galaxy. When such an event occurs in a distant galaxy, it becomes a beacon visible across billions of light years. By measuring the peak brightness of the explosion and comparing it with the observed brightness, the distance is determined. The earlier rungs provide calibration. The later rungs extend the reach. The ladder is not a seamless leap, but a sequence, each step resting on the one before it. Once distance is established, another phenomenon becomes clearer. Light from distant galaxies does not merely fade. It is stretched. Its wavelength lengthens. Time itself is stretched as well. A physical process that unfolds over a short interval at the source becomes slower by the time it is observed here. This stretching is not an observational error. It is a consequence of expanding space. As light travels through a space that is widening, each wave cycle is stretched. That applies both to the light and to the time encoded in what the light records. When a supernova explodes very far away, its light curve becomes stretched in observation. The duration of the outburst seems to run more slowly. This is not an illusion. It is a direct sign that the space between you and the event has changed while the light was traveling. Because of this effect, time becomes part of the measurement of distance. Not only brightness, but the rhythm of the event carries information. The universe does not only tell you how far it is, it tells you how it expanded along that path. The distance ladder, therefore, is not only a tool for measuring space, it is a tool for measuring history. Each distance corresponds to a moment in the past. Each degree of stretching reflects the state of the universe when the light set out. This changes how observation is understood. You do not see galaxies at fixed positions. You see them at different stages of the universe. Nearer is younger, farther is older. Space and time merge into a single measurement. Of course, the ladder is not perfect. Each rung has error. When errors accumulate, small differences become important. Calibration must be continually adjusted, improved, and cross-checked by many independent methods, not to achieve absolute precision, but to keep the story consistent. In that process, tensions appear. Independent measurements do not always match perfectly. The expansion rate inferred from the nearby universe and from the distant universe can differ slightly. These differences are not hidden. They are recorded as signals that something has not yet been fully understood. The distance ladder is therefore not only a measuring stick, it is a test of theory. When the yardstick and the model disagree, the problem does not lie simply in the yardstick or in the model. The problem lies in the gap between them, where knowledge must be expanded. What matters is that this ladder was not built in a single moment. It is the result of generations of observation, correction, and patience. Each rung is a compromise between what can be observed and what physics allows. No rung is complete on its own. When you look up at the sky and hear about enormous distance numbers, what matters is not the number, it is the structure of the measurement, a chain of inference anchored in light, time, and expansion. A way of reading the universe that does not rely on intuition, but on rhythm. Time is stretched, light is stretched, and within that stretching, history is preserved. The distance ladder allows you to place each fragment of memory in its proper position, not to complete the picture, but to keep it from being distorted. And in learning how to measure distance, humanity learns something more important. That to understand the cosmos, you do not need to stand at the center. You only need to know how to read very small, very distant signals, and accept that every number is an invitation to keep listening. There are things that cannot be seen with light, not because they are too distant, but because they emit no light at all. For a very long time, the universe seemed readable only through photons that arrive late. Then another channel opened. No light was needed. No images were required. Only the vibrations of space itself. Gravitational waves carry no color. They have no spectrum. They are not blocked by dust or gas. They are extremely small ripples propagating through the fabric of space and time. As they pass, distances between things stretch and contract, incredibly slightly, incredibly briefly, yet real. The idea arises from understanding that gravity is not merely a pulling force, it is geometry. When massive objects move violently, that geometry does not remain still. It vibrates. And that vibration propagates outward, like ripples spreading when an object falls into a lake. For most of observational history, these vibrations existed only on paper. They were too weak. No instrument was sensitive enough to detect changes smaller than the diameter of an atomic nucleus. Experimentally, the universe remained silent. That silence ended when humanity learned to measure distance with unimaginable precision. 2 points separated by kilometers, yet their change must be known to less than 1,000th of a proton's diameter as a ripple passes through, not to see, but to sense. When the first signal was recorded, it did not arrive as an image. It arrived as a rhythm, a short oscillation, rising and fading, a sound translated from data, not sound in air, but the rhythm of space itself. The universe, for the first time, was heard. The source of that rhythm was not an ordinary star. It was two extreme objects orbiting each other, spiraling inward, then merging. In the final moment, an enormous amount of energy was released not as light, but as gravitational waves. Space was stretched, then relaxed, and the ripples spread across the universe. By the time those waves reached here, they had traveled for more than 1 billion years. Unweakened by matter, undeviated by obstacles, they carried direct information about the event that created them. No intermediary, no medium, a primordial message. From that moment, the way you approach the universe changed. Light gives you surface images. Gravitational waves give you internal motion. Where light cannot escape, gravitational waves still pass through. The darkest, densest regions are no longer completely sealed. This opened a new sense for awareness, not replacing light, but complementing it, a form of hearing rather than seeing. When two extreme objects merge, light may be swallowed, but gravitational waves still carry the story outward. From then on, each major event adds a new record, not an image of a galaxy, but the rhythm of space, not color, but amplitude, not position, but kinetic energy. There are events detected simultaneously through both light and gravitational waves. In those cases, the two channels converge. One tells you where, the other tells you how. For the first time, the universe is observed through multiple messages at once, no longer a monologue of light. Gravitational waves also carry another promise. They can arrive from times that light cannot reach. In the earliest moments of the universe, when everything was too dense for photons to escape, space itself could still vibrate. If such vibrations exist, they carry traces of an extremely early moment, before any images. If one day such signals are detected, they will not be pictures of the beginning. They will be the universe's first heartbeat, not the light of dawn, but the vibration of structure as it came into being. What matters is that gravitational waves are difficult to misinterpret. They are not affected by intervening matter. They are not scattered. They require no optical correction. When they arrive, they carry information almost intact. This makes them a new standard for testing theory. When prediction and observation coincide in this domain, confidence grows in a different way. Not because the images are beautiful, but because the rhythm is correct. A resonance between mathematics and reality. Gravitational waves also highlight a subtle truth. The universe does not need to shine to communicate. It can vibrate. And in that vibration, information is transmitted without a carrier of light. No eyes are required. Only instruments refined enough to listen. When you think of the night sky, its quiet can be deceptive. Beneath that apparent silence, vibrations are constantly passing through. From distant mergers, from violent motions, from events that light never tells, the silence of the universe, therefore, is not an absence of activity. It is the limit of an old sense. When a new sense emerges, silence becomes background rhythm. Gravitational waves do not make the universe noisy. They do not overwhelm light. They add depth, a dimension previously missed, a dimension of pure motion. In learning how to listen to the universe, awareness itself changes. Not all understanding comes from images. Not all stories are told with light. Some chapters are written only in vibrations. When you accept that space can vibrate, that time can stretch and contract, that information can arrive without light, the way you define reality expands. The universe is no longer a static picture. It is a very long symphony, where each major event leaves a note that travels outward, slowly, but never completely disappears. And from the moment the universe is no longer silent, listening becomes an essential part of understanding. Not to hear sound, but to sense a structure that is speaking about itself. There are boundaries, not marked by fences or horizons. They exist as a threshold of silence, where every familiar signal no longer returns. A black hole is such a boundary, not an object in the ordinary sense, but a region of space where understanding reaches the limit of itself. When a sufficiently large mass is compressed into a sufficiently small volume, the space around it curves so intensely that every path leads inward. Light, the fastest thing nature allows, has no escape route, not because light is weak, but because the structure of space has closed in on itself. From the outside, only an invisible boundary remains. Inside, every description becomes uncertain. That boundary does not glow. It does not reflect. It only marks the point of no return. Everything that crosses it vanishes from the reach of observation. There is no warning signal, no explosive spectacle, only the absence of information. What makes a black hole special is not its size or its pull, but its role in awareness. It is where the strongest theories no longer speak the same language. Quantum mechanics describes the very small, relativity describes the very large. At a black hole's center, these two perspectives overlap, but do not reconcile. Seen from far away, a black hole can be described by a few simple quantities: mass, spin, charge. Every other detail seems erased from the observable surface. This suggests a deep paradox. If information is erased, where does the past go? If information is not erased, where is it stored? This question is not an intellectual game. It touches a foundational principle of physics. Information, in modern understanding, is not allowed to disappear. Yet a black hole seems to do exactly that each time it swallows an object. This tension is not in technical details. It lies in the foundations of how reality is understood. As observational tools advanced, black holes ceased to be entirely invisible. What appears is not the black hole itself, but its shadow. Light is bent so strongly that it forms a bright ring around an absolute dark region. That ring does not tell the story inside. It only shows where the boundary is. A black hole's shadow is an image of a limit, not the limit of instruments, but of direct knowledge. You can see the edge, you can measure the influence, but you cannot look inside. Not because tools are lacking, but because the nature of space there does not allow it. Yet black holes are not the end of discovery. They are the beginning of new questions. When matter falls in, it does not vanish from every effect. Before it crosses the boundary, it heats the surrounding environment. It emits radiation. It stirs space. These traces allow indirect inference. There are enormous black holes at the centers of galaxies. They do not destroy the galaxies. On the contrary, they coexist in a long-term balance. Gas and stars orbit around them, affected but not swallowed en masse. This shows that black holes are not wandering monsters. They are stable parts of large-scale structure. On rare occasions, two black holes draw close and merge. Space then vibrates violently. Gravitational waves carry information about mass, spin, and released energy. This is one of the few times the universe lets you hear what happens near the dark boundary. But even in those moments, the interior remains sealed. No signal crosses the final boundary. The black hole protects its secret through the very structure of space. This leads to another way of seeing. Black holes are not only where knowledge stops, they are where knowledge is tested. They force theories to confront each other. They force awareness to accept that some questions cannot be answered through direct observation. There are ideas suggesting that information does not vanish, but is stored on the boundary surface. Other ideas suggest that information is emitted extremely slowly over long timescales. These ideas are not yet confirmed, but they show the effort to preserve principles in a world unfriendly to intuition. When you think of black holes, it is easy to fall into images of destruction, but the core is not destruction. It is limit. A black hole marks the place where familiar methods no longer apply, where you cannot ask more simply by seeing more clearly. In the history of science, such limits do not weaken knowledge, they mature it. When you know you cannot look inside, you learn to ask different questions. Not what is inside, but how the boundary works. Not where information is, but what information means. Black holes also remind you of something important. Reality was not designed to be transparent. It has no obligation to be easy to understand. There are structures that exist independently of the ability to observe them. Knowledge is not possession, but approach within permitted limits. When the night sky is quiet, black holes do not appear as points of light. They appear as the stability of orbits, as the vibration of space when a major event occurs. They do not speak, but their silence carries weight. At the boundary where light stops, knowledge does not vanish. It changes form, from direct description to inference, from image to structure, from answer to question. And in confronting black holes, awareness learns an important lesson. Not everything must be seen to matter. Not every story has a clear ending. Some chapters of the universe are written in silence, and that silence forces you to listen more closely to what can still be known. There is a quiet but persistent question that follows the entire journey of understanding the universe. When everything falls into a black hole, what happens to its information? Not matter, not energy, but information. State, configuration, history. If it all disappears, a foundational principle of physics collapses. If it does not disappear, then where is it? This paradox does not arise from philosophical speculation. It arises from a conflict between two pillars of modern understanding. One side says information cannot be destroyed. The other shows there are places in the universe from which nothing can return. These two statements cannot both be true, unless our understanding of reality needs to be expanded. Black holes pose that question directly. When an information-bearing object crosses the boundary, no signal comes back out from inside. From the outside, every detail seems to be wiped clean. But if information truly vanishes, then the future cannot be fully inferred from the past. Reality becomes irreversible at the deepest level. To avoid that, a bold idea emerged. Perhaps information does not go inside the way we think. Perhaps it is recorded at the boundary, not as a copied image, but as a refined encoding on the surface that separates what can be observed from what cannot be observed. From this idea, a new way of seeing space was born. Perhaps all the information inside a volume of space does not reside in that volume itself, but on the surface surrounding it, like a three-dimensional image produced from a two-dimensional film. Three-dimensional reality could be a projection of a lower-dimensional structure. This concept is not a simple metaphor. It was formed from rigorous calculations about entropy and area. When considering the maximum amount of information that can be contained in a region of space, the result does not scale with volume, but with surface area. This runs against familiar intuition, yet it matches what black holes suggest. If that is true, then the world you experience is not the final foundation. The depth you perceive may not be where information resides. Three-dimensional space could be an emergent phenomenon, like an image rising out of a hologram. In a hologram, each small part of the film still contains information about the whole image, not complete in detail, but sufficient to reconstruct the overall structure. In a similar way, if reality is holographic, then each region could reflect the whole at some level, not through pictures, but through relations. This view changes how you think about position. There is no longer an absolute center. There is no longer an inside completely separated from an outside. Everything is defined by boundaries and relationships. Information does not lie deep within space. It lies on the edge, where laws meet. This also changes how you think about dimension. Three spatial dimensions may not be fundamental units. They may be the result of arranging information on a lower dimensional structure. The reality you sense may be an expression, not an origin. If so, a black hole is no longer a place where information disappears. It becomes a place where information is compressed onto a surface. The boundary is not a wall of destruction, but a recording face. Everything that falls in leaves a trace, even if it cannot be read directly by light. The information paradox, in this frame, is no longer an unsolvable contradiction. It is a sign that intuition about space needs updating. Reality is no longer well described as objects sitting inside a three-dimensional box. It is described by relationships encoded on the boundary. This carries a profound consequence for awareness. If information is fundamental, then matter is only one way information expresses itself. Space and time are no longer fixed stages. They are outcomes of information being arranged according to certain rules. Seen this way, the question is no longer where an object is, but how information is linked. No longer what the inside contains, but what the boundary encodes. Reality becomes less like a solid block and more like a network of relations. This does not mean the world you touch is an illusion. It means its foundation is not like your sensation. Just as a hologram image still has depth though it is created from a flat surface, reality still has structure though it is generated from a lower dimensional description. The hologram concept also redefines the role of the observer. If information lies on the boundary, then observation is not looking through into an inside, but reading encoded relations. Awareness does not penetrate reality. It decodes structure. This creates an overlap between physics and philosophy. Reality is no longer a collection of independent objects, but a self-sustaining information system. Understanding does not come from peeling apart each piece, but from recognizing how the pieces relate to one another. The information paradox, therefore, is not only a technical problem, it is a door opening onto another way of seeing existence. When space is no longer the final foundation, familiar questions must be asked again, not to make them more vague, but to make them more consistent with what the universe shows. In this context, black holes are not where knowledge collapses. They are where knowledge undergoes a phase transition, where old assumptions are no longer enough, and new structures begin to appear, not loudly, not abruptly, only through a deep adjustment. When reality is no longer three-dimensional in the foundational sense, you do not lose the world. You only lose one interpretation. And in that gap, another understanding appears, an understanding that treats information as the root, boundaries as the center, and space as a consequence. You do not need to accept it immediately. You do not need absolute belief. What matters is recognizing that paradoxes like this are not signs of failure. They are signs that awareness has reached the edge of an old framework. And at that edge, Reality begins to reveal shapes that three-dimensional intuition is no longer sufficient to grasp. Galaxies are not static structures. They do not exist like unchanging cities suspended in space. Each galaxy is a long process, beginning with the fragile gathering of matter, passing through eras of bursts and collisions, and then gradually entering a state of quiet that can last for billions of years. This life cycle has no noise. It unfolds at a pace so slow that human intuition struggles to grasp it. The birth of a galaxy does not begin with light, but with gravity. In the young universe, matter was not evenly distributed. Regions that were slightly denser began to pull surrounding matter toward themselves. Dark matter played the role of an invisible framework, guiding ordinary gas as it gathered. There was no design, no center, only law. When gas is compressed strongly enough, temperature rises, enormous clouds collapse, the first stars ignite. Light appears not as a spectacle, but as an inevitable consequence of density and heat. From that moment, the galaxy enters its youth, a phase that is chaotic, violent, but rich in energy. In this youth, stars form rapidly. They consume gas, emit radiation, and then die in powerful explosions. These deaths do not end the story. They enrich the environment with heavy elements, allowing later generations of stars to become more complex. The galaxy learns how to recycle itself. No galaxy grows alone. On large scales, space is a network. Galaxies move along filaments of matter, drawing closer to one another over time. When two galaxies meet, stars do not collide with stars. The distances between stars are too great. What happens instead is that orbits are disturbed, gas is compressed, new stars are triggered into existence. Mergers are turning points in a galaxy's life cycle. Two separate structures gradually lose their original identities. They spiral into one another, stretch into long stellar streams, and then settle into a new structure. In this process, energy is redistributed. Shapes change. The rate of star formation may surge, then suddenly decline. At the centers of many galaxies are extreme regions, places where gas concentrates, where motion is dense. These regions can blaze for a time, then fade. When the gas supply is exhausted or pushed outward, activity gradually decreases. The galaxy enters middle age. In this stage, shape becomes more stable. Fewer new stars are born. Light comes mainly from older stars. The color of the galaxy shifts toward red, not because it is dying, but because it has consumed most of its easily accessible fuel. The decline of a galaxy does not occur through collapse. It occurs through silence. The rate of star formation drops. Gas is held at high temperature or swept away by earlier interactions. Stable orbits dominate. There are no great events, only time. In the modern universe, many galaxies are already in this phase. They drift through space carrying hundreds of billions of old stars, shining steadily but without drama. They do not tell their story through explosions. They tell it through endurance. What matters is that this life cycle has no clear endpoint. A galaxy may merge again, reactivating part of its activity, or it may continue drifting in quiet until the universe becomes too diffuse for new interactions to occur. Its fate is not fixed. It depends on environment. When you look at galaxies at different distances, you are looking at different stages of this life cycle. Nearer means older, farther means younger. Space becomes a timeline. Each image is a slice. This changes how you understand existence. Galaxies do not exist to reach a perfect form. They exist to transform. There is no ideal final state, only different phases of the same process. Within this life cycle, there is no preference for life or consciousness. Those things, if they appear, are merely local consequences of very specific conditions. Most of a galaxy's life unfolds in silence, without observers, without questions being asked. Yet that silence highlights the present moment. When a galaxy still has enough gas to form stars, when light is still abundant, when structure is stable enough to persist for long spans of time, this is not a common phase across the full life of the universe. The life cycle of galaxies also reflects a broader principle. All complex structures emerge in the interval between two extremes, too chaotic, and nothing endures, too static, and nothing new arises. Galaxies survive longest in the transition zone. When you think about the birth and decline of galaxies, what stands out is not scale, it is rhythm. A rhythm that does not hurry, that has no climax in the human sense, only the continuous adjustment of matter under law. Within that rhythm, human awareness appears as a very late phenomenon, a byproduct of cycles that last billions of years, not central, not predetermined. And when a galaxy enters silence, it does not vanish. It continues to exist as a repository of the past, old stars, stable orbits, traces of earlier mergers. All of it is preserved, without needing to be told. The life cycle of galaxies, therefore, is not a story of birth and death in the familiar sense. It is a story of transformation and continuation, a story written in gravity, gas, and time. It requires no witness. Yet when you look up at the sky, you are seeing different chapters of the same book, being read slowly. In the silence of the universe, there is a direction that every process follows, even though no one commands it. No purpose is required. No observer is needed. That direction is defined by entropy, not as an abstract concept, but as a measure of dispersion, of the irreversible spreading of order into microscopic disorder. When a hot object is placed next to a cold one, heat always flows in one direction, never the reverse without intervention. When stars burn fuel, energy is released and then dissipates. When structures form, they consume differences in order to exist. Every such process increases entropy. There are no exceptions. The universe, considered as a total system, follows this rule as well. In the beginning, it existed in a special state, hot, dense, yet low in entropy in a very subtle way. This allowed structures to form, allowed differences to exist, allowed time to have a direction. As the universe expands, space stretches, and energy becomes diluted. Temperature differences gradually diminish. Sources of free energy, the kind that allows work, transformation, and complexity to exist, are slowly exhausted. Not because energy disappears, but because it becomes too evenly distributed. In the present era, stars are still burning. Galaxies still have structure. Processes still have momentum. But this is not a permanent state. It is an interval, a brief segment in a very long timeline, where entropy has not yet reached its maximum. When stars run out of fuel, light fades, concentrated sources of heat disappear, objects cool. The remaining small differences are smoothed out through increasingly rare interactions. The universe moves closer to thermal equilibrium. Thermal equilibrium is not destruction. It is the end of possibility. When every region has the same temperature, there is no energy flow, no capacity to do work, no mechanism to create new structure. Time, in the physical sense, loses its direction. In that state, there are no major events, no climax, no moment of collapse, only an extended stillness, a cold, dark, nearly empty universe, where everything exists in a steady condition with no significant change. Heat death is not an apocalypse in the dramatic sense. It does not arrive as an explosion. It arrives as an infinite settling, a process whose individual steps are so small they are hard to notice, yet whose total effect is irreversible. In this context, all complex structures are temporary. Stars, planets, galaxies, and even biological systems, if they exist, all depend on energy differences. When those differences vanish, their foundations vanish as well. Entropy, therefore, is not just a number. It is the deep rhythm of time. It explains how the past differs from the future. It determines why memory exists, why processes occur, and why complete reversal is impossible. In a universe at thermal equilibrium, memory cannot form, not because matter is absent, but because there is no sustained change. All states are equivalent. There is no reference point to distinguish before and after. Time becomes operationally meaningless. This places the present in a special position, but not in a privileged sense, only a rare one. A phase where entropy is low enough to allow structure, yet high enough to allow processes. A narrow window in which complexity can exist. Seen this way, Life is not the goal of the universe. It is a consequence of a temporary condition, a way matter organizes itself to delay equilibrium by increasing entropy elsewhere. Life does not oppose entropy. It exploits it. Every organism, every civilization, every cognitive system exists because of energy flow. When that flow stops, all activity stops with it. There is no tragedy, no loss in the subjective sense, only the end of operational possibility, heat death. Therefore, does not negate meaning. It places meaning in context. Meaning does not come from permanence. It comes from finitude. A moment has value not because it lasts forever, but because it occurs within a very narrow range of enabling conditions. In the very distant future, when the last stars fade, when rare particles drift through diffuse space, when interactions become exceedingly infrequent, the universe will not know that it was ever complex. There will be no global memory, no central record, only successive equilibrium states, but the present is not there. The present lies in the transition zone, when light still arrives, when structures still change, when entropy is increasing but has not yet peaked. This is the condition that allows questions to exist. Entropy does not tell you what you should do. It issues no commands. It only describes a tendency, and within that tendency, all actions are temporary but not meaningless. Temporary does not mean without value. When you understand heat death, there is no need for pessimism, no need to seek escape. There is no global escape from entropy, but there is space for experience, for understanding, for formation in the interval between. The universe does not aim for life. It aims for equilibrium. Life appears because equilibrium has not yet arrived. Awareness appears because differences still exist. Questions appear because time still has a direction, and precisely because of this, understanding entropy does not diminish the present. It sharpens it, a rare moment in a very long history where everything has not yet frozen into uniformity. Heat death is not the conclusion of the story in a narrative sense. It is the backdrop, a baseline state where all motion has finished. But before reaching it, there is a very long stretch where light, structure, and awareness coexist. You are within that stretch, not at the center, not at the peak, simply at a point where entropy has not yet completely won. And because of that, questions about the universe can still be asked. While time is still flowing in a direction that can be recognized, consciousness did not appear at the same time as the universe. For most of the history of existence, there was no one to observe, no one to ask questions, no one to remember. Particles moved, stars formed and burned out, galaxies merged and drifted into silence. Everything happened without needing to be known. Then, at a very late moment, on a very small planet, in an unremarkable galaxy, matter began to organize itself in a new way, not only to persist, but to reflect, not only to react, but to recognize. Consciousness emerged not as a miracle, but as the consequence of a rare chain of conditions intersecting at the right time. Consciousness is not something that fell into the universe from outside. It formed from the very substance of the universe itself. Atoms forged in the cores of ancient stars became part of nervous systems. Forces that once governed galactic motion became the foundation for electrochemical signals. There is no clear boundary between physics and awareness, only levels of organization. When consciousness appeared, something unprecedented occurred. For the first time, the universe gained the capacity to observe itself, not in a mystical sense, but in a structural one. A part of reality began constructing models of the whole of reality, incomplete, not perfectly objective, but sufficient to ask questions. Those questions are not about purpose. The universe does not ask why it exists. It asks because it can ask. Consciousness does not require an ultimate reason to appear. It appears because conditions allow high-level information processing, because there is sufficient free energy, sufficient stability, sufficient time. What is striking is that consciousness does not alter the laws. Stars still burn as before. Galaxies still collide along their old trajectories. Entropy still increases. But the way reality is experienced changes. For the first time, a distinction arises between existence and being known. When you look up at the sky, you do not merely receive light, you assign meaning. You connect scattered data into stories. You recognize structure, rhythm, and law. These things are not embedded in the light itself. They emerge through interpretation. Consciousness, therefore, is not the center of the universe. It is an interface, a layer where physical information is translated into experience. There is no guarantee this layer will endure. It depends on extremely fragile conditions. A small environmental change, and it disappears. Yet, during the interval in which it exists, consciousness creates something distinctive. It allows reality to have local memory, not a complete cosmic memory, but temporary repositories of what has occurred. Maps, theories, narratives. These do not change the universe, but they change how one part of it understands itself. There may be other places, other times, where consciousness also arises. Nothing in physics forbids it, but nothing guarantees it either. Consciousness is not inevitable. It is a possibility. This makes the present moment special in a non-romantic way. Not because it was chosen, but because it is rare. A span of time when physical conditions permit self-reflection, when light can still arrive, when structures are sufficiently complex, when entropy has not yet flattened all differences. In this context, consciousness is not the final goal of the universe. It is a phase, a stage in which matter reaches a level of organization high enough to model itself. When that phase ends, the universe loses nothing essential. It simply continues along its general trajectory. But while that phase exists, questions are asked, not to alter the fate of the universe, but to understand one's position within it. Not to seek absolute meaning, but to recognize context. Consciousness also clarifies something fundamental. Understanding is not an act of domination. It is an act of interaction. You do not stand outside the universe to observe it. You are part of it, using its own laws to describe it. There is no completely external vantage point. This does not render knowledge entirely subjective. It makes knowledge conditional. Models are valid within the scope in which they are tested. Answers are correct within the context of available data. When data change, understanding adjusts. Consciousness, therefore, is not a summit. It is a continuous process of self-correction, an open system, always capable of error, but also always capable of learning. Seen this way, the question of meaning does not require an eternal answer. Meaning is not imposed from outside. It arises in the relationship between the capacity to understand and what is understood. When that relationship exists, meaning appears. When it ends, meaning ends as well. In the very distant future, when the universe approaches a cold, uniform state, when complex structures no longer exist, when energy flows cease, consciousness will have no place, not because it failed, but because the underlying conditions no longer support it. But the present is not there yet. The present still has light, still has motion, still has questions, and in this interval, consciousness functions as a moment of reflection, not for the universe to know it exists in a subjective sense, but for one part of it to recognize the structure of the whole. Cosmic consciousness, therefore, is not the universe thinking like a human. It is the universe reaching the capacity to be thought about. A subtle distinction, but a crucial one. When you ask questions about the origin, structure, and fate of everything, you are not standing outside the story. You are a segment within it, a very brief, very fragile segment, but one capable of connecting data spanning billions of years. And in that moment, reality does not change, but the way it is seen does. The universe does not need consciousness to exist, but when consciousness appears, the universe gains a new capacity, the capacity to be looked back upon, if only for a moment, before continuing its long journey in silence.